Okay, this is it. And by the way, the schedule, which I should have left up there, I had homecoming week, but the schedule for this week is right here. I haven't put it up yet. I finished it before I put it up. But homework, lesson 8, plus start the review. I have a packet coming, but I don't have that today. Sorry. Correcting your homework quiz in class, so it won't take us all time in correcting homework. And I'm going to give you a little homework quiz tomorrow, just to make sure that everything's okay. So tomorrow you have that little homework quiz. You have a review packet. That's it. And getting ready for your test, which is Wednesday. Thursday I will not be here, but Mrs. Ellis will be covering for me. I believe we're going to do it in-house. And so then she teaches the same thing, so it'll be easy, relatively speaking. So now I'm going to go back here, and we're going to talk about parallel lines. I kind of like these problems. They're like puzzles. Yes, so put this on Open Schoology, open this file, and then put it in Notability. If you don't have your iPad or want to work paper pencil, that's fine. I've got some paper that you can use, or you can bring your own paper. Somewhere I got to find it. Or if your iPad's dead. Just a little homework quiz. It's not going to be long, and I'm hoping we can correct it in class. It's just a homework quiz. Now, homework quizzes are 15% of your grade.
So what's happening tomorrow, right?
Is a review.
So there's 15 like percent of our whole
Who wanted paper?
grade.
The thing about this is you're actually better off working on your iPad because,
Thanks. Then you have your notes right there.
well, you do. And not only that, there's lots of pictures. And you're going to have to draw on your pictures. Okay, remember about food, if you are bringing it in, that you must throw your garbage away. I'm not mom. More like grandma. Okay. By the end of this lesson, you will be able to determine the relationship between 3 special types of angles formed by a transversal cutting parallel lines. This line here that cuts through these other 2 that are supposed to be parallel, don't look parallel, that's called a transversal. You have probably seen a lot of these things before. I don't know that this is 100% new. The vocabulary might be. Now, I can determine if lines are parallel based on the angles I'm given. Okay, so let's get started here. Transversal is a line intersecting 2 or more other lines in the plane. Now, in particular, they gave a picture where those are parallel. At least they look parallel. And when I look at parallel lines, what appears to be true generally is true. I won't say that all the time. You usually can't assume. But if I make a nice picture, I can look at that and I can say, oh, I think I have some congruent angles. For sure, I have some supplementary angles. Which ones are supplementary? Angle 1 is supplementary to what? Supplementary means they add up to 180, but let's make a straight angle. 1 and angle 2. And angle 1 and supplements angle 3. Okay. I already know that. But you know what else I already know? I know about vertical angles. Which one's vertical to angle 1? So angle 1 and angle 4 are vertical. If they're vertical, what's true about their measures? The angles are congruent. And I know it seems picky about being picky about the vocabulary, but it has to be that way so we all understand it in the same way. That's why we have to be careful about that. Okay, so I have some congruent angles. I have angles that add up to 180, and generally what appears to be true is true. But let me give you another example where the lines are not parallel. Today we're going to be focusing on parallel lines. But you could still have this situation, and there's the transversal. They don't have to be parallel to have a transversal. I'm going to change that to red. So this is the transversal. But if the lines are parallel, there's some really cool things that happen. I get some congruent angles. Okay, ready? Okay, corresponding angles. What are they? You might have seen this in the past. I don't know. Angles, and I don't necessarily know like how some of this is written, but we'll see. Angles on the same side or corresponding sides of parallel lines. So if you're talking about corresponding, I have this. This one is in the same position as that one. That's what you mean by corresponding. If you were to pick this diagram up and put it on top, they should line right up on top of each other. That was pretty good for freehand. Do you see what I just did? Those are the corresponding angles. There's more corresponding angles than that, but these correspond. They're in the same relative position. They're on the same side of the transversal, but they're in the same position. So it's really hard to define. So which ones are corresponding? I just did, basically I did angle 2, and I did angle 6. And you could just write it this way. Because we are lazy in math. We don't want to write too much stuff, so that's easier to write. Can you give me another pair? Are we ready or not? Angle 1 and angle 5. So on the same side of the transversal, in the same position. So angle 1 corresponds to angle 5. Transversal is just a line that cuts two other lines, and when that happens, we form angles. There's another pair of corresponding angles. 7 and 3. And this is ACT material, by the way. The last problem we're going to do on this lesson is, well, probably a little more complicated than ACT work. And if you're going to go to college, you have to think about ACTs. And there's one last pair. 8 and 4. Now, what I'm going to do is pull this green one out here. And if I had a better picture, what letter does that kind of look like? Makes an F. Corresponding angles would make an F. And you're saying, well, the other ones don't. They do if I rotate. Get these back up there where they go. Kyle. There you go. Okay. So if I pull the purple one out, I hope it works. It's a backwards F, but what do I do if I flip it? Left, right. You can kind of see the F there. Yeah, it's still, but that's how you know. I want to put it back though. What appears to be true about your corresponding angles? What if I were to measure angle 1 and I measure angle 5? What do you think is true about their measurements? They're equal. That's our conjecture. Oops, I'll forget that. If you have parallel lines cut by a transversal, then the corresponding angles are congruent. Now, I don't like to write all that out, so I'm going to shorten it up a little bit. You can write it all out if you like. Okay, Karen? So it's if we have two parallel lines, so two parallel lines, and I draw the picture of parallel lines for the word parallel. Then I don't have to write the word. Cut by a transversal, there's no way I can shorten that. Except I'll keep transversal by trans. Yes. Then the corresponding angles, there's a comma there. I don't have to write the word then, but the corresponding angles are congruent. This is the part you're not going to like about geometry. When we do proofs, we have to write these things out. That's that if-then statement. Now, it's a conjecture because we're not going to prove it. We just observed it. We think that's true. We could prove it. We're not doing that. At least not today. Okay, so I have two parallel lines, and you cut them with the transversal. The corresponding angles, all corresponding angles will be congruent. So every place you see corresponding angles here, I have that in the right place. No, that's better. So these are congruent. These are congruent. These are congruent. And these are congruent. So when I get done with this today, you're going to have a big complicated diagram, like a puzzle. You ready? Okay, these are alternate interior angles. Okay, so first let me start with the easy part, interior. This is the inside. It's the region trapped between the parallel lines. Okay? If I'm going too slow, I can go faster. Todd, got that? The exterior are on the outside of those lines. So it's all of this. I can't make it wider. That's exterior, and this is exterior. And the vocabulary can be overwhelming. Now I want alternate interior angles. So I'm looking at this region inside this line and this line right there, but I want them on opposite sides of the transversal. So that would be 4 with 5. So angle 4 and angle 5, whoops, are alternate interior angles. And you can abbreviate it just like that. Too confusing if I just use letters like AIA. We'll get there soon enough. And there's another pair. Anybody know where the other pair are? Interior? Yep, 6 and 3. And what letter am I making here? It's a Z. So if you get in trouble, because on the ACT they may ask for alternate interior angles, and that's the Z. And what do you think is true about angles? What's true about 4 and 5? What's true about these measures? They're equal. Angle 4 is congruent to angle 5, and angle 3, now it's up 2, so you know it's not going to be less than 90. Angle 3 is congruent to angle what? 6. That's it. There are a lot of corresponding angles, but there's just 2 pairs of alternate interior. And that's my conjecture. That if 2 lines are cut by a transversal, the alternate interior angles will be congruent. I'll move this up. So if 2 parallel lines, you have to know they're parallel, cut by a transversal, then alternate interior angles are congruent. Okay, guys, stop that. Alternate interior angles are congruent. It's going to be kind of like a Sudoku puzzle. So once you start getting one and then you get another one, you can start figuring out, well, what numbers does this have to be as we go through this. Okay? Todd and Garrison, you got that?
Yes.
Todd and Garrison. Okay, we ready to go on? One more type of angle. Alternate exterior angles. Use the words we have here. They are on opposite sides of the transversal. That's why they mean alternate. And exterior means they're in the exterior region. And if you remember, I colored that with the blue. So it's this. So these are exterior, but I want on the opposite side of the transversals. Yes, it is. So this is, you know where the toughest lesson I think in the unit was? Was lesson 6. I know, that's hard. Oh. Okay, exterior angles that lie on different parallel lines and on opposite sides of the transversal. So they're angles that are on the exterior of the parallel lines, and they are on opposite sides of the transversal. So let's find one. If I take angle 1, now that's an exterior angle. Now I'm going to go to the other one, not the corresponding one, but the exterior angle down here is either 7 or 8, but it's on the other side of the transversal. Yeah. I don't have a little trick for these guys. Okay, guys? I get these little, like that. Do you think they're congruent? Yes. Okay. Give me the other pair, because there's one other pair. 7 and 2. I just don't get a nice little pattern. Angle 7 is alternate exterior to angle 2. Probably easier to understand this than it is to write it out. And they do look like they're congruent. So we'll put that little symbol in here and put that little symbol in there. Okay, Curran? Yes. Okay. There is the conjecture once I cut it away. Okay. So if I have two parallel lines, the lines have to be parallel. I have to say I have two parallel lines, and they're cut by a transversal. Then alternate exterior angles are equal in measure, they're congruent. Okay, we ready? What do you think will happen if we reverse it? Okay, Sydney? Math. What if you know the alternate exterior angles are congruent? What would have to be true about the lines? They're parallel. Okay? So the reverse or the converse of this is true. Okay, can we name all the angles that are congruent? Starting with angle 1. Angle 1 is congruent to angle 5. There's a whole bunch. Whoops. Not that symbol. Angle 5. What else? What else are 1 and 5 congruent to?
4, 8.
4 and 8.
And also the same with 6, 7, 3.
Okay. Now, those are acute angles. The other ones left over are obtuse. Angle 2 is congruent to angle 3. You can see that? And that's congruent to what? Which are the obtuse angles here on the second set? 6 and 7. What appears to be true generally is true. Here's the one time, if you draw a good diagram, you can make some assumptions. So guess what? That's it. Those are the ones that are congruent. Those pairs, those 4 angles and those other 4 angles. But what else is true? What's true about 1 plus 2?
180.
Whoops. And I don't want to write all these out because there's a lot. So what happens here? Either your angles will be congruent or they'll be supplementary. Remember, this means supplementary. So I'm going to write that. So either, let me slide it up a little bit. When you're looking at parallel lines, either the angles are congruent or they're supplementary. That's all that's going to happen. If two lines are cut by a transversal, parallel lines cut by a transversal, that was important. And then I can have this little symbol. I don't want to write the then. I can use this. It's an equals with a little arrow. It means implies, because it makes it easier to write. So when you look at these diagrams, you're either going to subtract your number from 180 or it's going to be equal to the number you're looking at. You just have to decide. It's obvious 7 and 8 are not congruent. I mean, look at it. 7's bigger than 8. So use that. Use your logical reasoning when you work with these problems. Oopsie. Okay, parallel line conjecture. Parallel lines conjecture. If two parallel lines are cut by transversal, then the corresponding angles are what? Congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Well, they're not all congruent. Just the corresponding angles are congruent. They're either congruent or they're supplementary, depending on where you are. Now, the converse means I'm just going to reverse this. If I have corresponding angles congruent, then the lines are parallel. I'm going to write it that way, except I'm going to show you just a little trick, a nice little way to write this, and I'll reveal the way it's written here. If I have corresponding angles congruent, because are you like me? You don't want to write a bunch of stuff out, do you? This is the if part. Then I have this equals, that implies sign, that the lines are parallel. This is the then part. Short. Wait to see what I reveal here. It's not short. What if I have alternate exterior angles congruent? Then what will be true about the lines? They will be parallel. It's just the reverse of this. So you can already imagine writing the reverse of this. What's the last possibility? I missed the alternate interior. Alternate interior angles congruent implies that the lines are parallel. I don't know if the other teachers do that, but that's what I used to teach it. It's short and sweet, so I like that. So with the wordy version, if two lines are cut by a transversal to form pairs of congruent corresponding angles or congruent interior angles or congruent alternate exterior angles, then the lines are what? Parallel. If the lines are parallel, then I get all these angles congruent. If these angles are congruent, then I know the lines are parallel. They could ask that on the ACT. They might give you some measures and say, are the lines parallel? Or they might say, even better, which lines are parallel? So when you take the ACT, when you sign up for it, ask to get your test back. It's an extra $15, but that's priceless because now you know, you don't just get a score, you know which problems you got wrong. And then you can go back and work on those areas that you're weak in so that when you take the ACT again, and you will, you do a little bit better. It's an extra $15 to get the test back. I've seen the test. I know these problems are there, which is really helpful for me as a teacher. And we have, I think, just one problem we're going to do. Oh, yeah. It's a bear of a problem. That's what we're going to do. Are you ready? Well, wait to see it. Now, I have a hard time seeing it because it's blurry up here, and with my eyes, it's really hard for me to see it. Are we ready? You can go to the next page and start working on it. It's just a puzzle. But you got to read the whole thing, and some of us didn't look at some of the marks. The trickiest one to get is Q. And maybe, no, this is our lesson. Then the next one's homework. It's way easier than this. But these two lines up here are parallel. But guess what? You see this little mark over here? I didn't see this. That means this one's parallel to that one. So it really matters not where you begin, but we will begin, how about right here? Does that say 64? Well, how big is D then? 64. And you're going to just work your way around the problem. And then we all have the same problem of arithmetic. How do I get C? What's true about angle D and C? Add up to 180. And where's the problem? Some of you are going to forget to borrow. It's 180. Use a calculator if you don't like to do the arithmetic. Yeah. So this is going to be 10 minus 4 is 6. 7 minus 6 is 1. So it's 116. I love problems like this because I just work my way around the problem. But I will tell you, Q is the trickiest one to do. Alternate interior or alternate exterior. Yes, because How about C and B? Those are equal, aren't they?
For like
A is congruent to D. Careful, these are not parallel. And some people in the last class wanted to use this transversal and say like D and K were, or whatever letter that is, S, the D and S were congruent. They might be, but not necessarily. I don't know. But I do know that this line right here is parallel to that line right there. So I'm going to give you, which means all three of these are parallel, actually. That's how you're going to find Q. I know how to do it. I just didn't see it right away, though. So I'm going to do that, and then I'm going to hand back your homework quizzes. And so you can work on this. We're going to come back to this. I'm just going to pause things for a second. I want you to have a chance to do that. On the homework quizzes, I'm going to give them back to you. They're due tomorrow. You can correct them in class, or you can come in tomorrow morning. You can take it home, whatever your preference is. The test is Wednesday. I'm not available Wednesday morning. I have meetings. So, plan accordingly. Like even tonight, I'll leave at 3 as usual, and you might say, oh, wait, I want to go over this with you really quickly. And that's fine, but let me know. You can either email me if you think later in the day you want to meet with me, fine. Because I'm not in this room at the end of period 6. So I won't be in this room after school. If you just let me know you want to meet with me, then I'll come. But I have to know. Okay, so I'm going to pause this if I can find that. Now you get half points back. So let's say you got 17 out of 21. That's 4 points you missed, but you can get 2 of them back. If you end up getting, let's say it's 5 points that you missed, then you would get 2.5 points back. But I don't give you 2.5. I round it up. Yeah.